Okay, so what's the first strand of evidence? Fossil record. What's the second strand of evidence? This is what we've been talking about.
No, that's not it.
That's number 3.
Here's my notes. Structural morphological.
Yeah, structural and morphological evidence. Structural evidence, morphological evidence. These cladograms that we're doing are all based on what kinds of similarities? Structural similarities. We're actually looking at structures in organisms. I mean, the placenta is a structure. The foramen magnum, the hole in your head, is a structure. Paired appendages are a structure. So these are all structures that we're looking at to try to figure out relatedness. Now, with that, so this is the second one. And how many of you felt like this was pretty darn easy right up to
5.
bilateral symmetry?
6.
Okay, so let's draw some circles and squares here. Okay, so let's just look at these first 3 characteristics. So everybody's got cells with flagella on this list, right? Which organism only has cells with flagella and no other characteristics?
Sponge.
Sponge! Yes, they are real living things. No, they are sessile. They are not capable of motion, but they're a multicellular organism. Phylum Porifera, they're actually animals. So. Those are usually synthetic sponges, natural sponges. I should bring some in. I've got some somewhere. Look a little different. So we've got sponges that have cells with flagella, nothing else. What here has got some kind of symmetry and cells with flagella and nothing else?
Jellyfish.
Jellyfish. So we're going to put jellyfish here. And do you know what symmetry is?
It's symmetrical.
Things that are symmetrical. So bilateral symmetry, the prefix bi means how many? 2. Lateral means side to side. Bilateral symmetry is side to side symmetry. So if I draw that, it is generally bilaterally symmetrical. You are bilaterally symmetrical. Yes, you are. Starfish and jellyfish are not bilaterally symmetrical. They are what's called radially symmetrical. So you can divide them on axes like this. So they have symmetry, but they're not bilaterally symmetrical. It's a different thing. All right, so jellyfish have symmetry, but it's generally not bilateral symmetry. Okay, so let's go back and... Yeah, see, they put in starfish because there are starfish that have bilateral symmetry, but most of them don't. Most of them are considered to be radially symmetrical. So when we add bilateral symmetry, what do we get? And you know what? We're actually going to eliminate starfish because they complicate matters significantly. So we're going to eliminate starfish. I think that was a bad inclusion on this. So flatworms are bilaterally symmetrical. They do have some symmetry, and they have cells with flagella. And that's it for them. So we're going to put them in this next box. And flatworms include things like leeches, if you've ever been bitten by a leech. Little organisms called planaria that look like these little flat pieces of liver that swim in streams. You could go down with a net to Beaver Creek and find planaria in the wild. They're pretty cool. And they're used in labs a lot. When we add a mesoderm, what do we get here? Well, we see that pretty much who gets a mesoderm? Well, everybody who's left, this is where it gets complicated because we start to have a split. So a lot of organisms have a mesoderm, but then what's our next characteristic? We end up with a split because we have these 3 in whom the head develops first. And this is a literal thing, head first, butt first. Different organisms, as they're developing from a couple of cells, start developing either this end first or that end first, mouth or anus. And we can classify organisms on relatedness based on this. So we got 3 that develop head first and 1 left over here that develops butt first. What this means is that we have to do 2 boxes. So,
Wow. My mind is blown.
head first, or no, I'm sorry, it was butt first was the 1. Yeah, butt first is just 1 organism. If you already did this, don't panic.
Oh, I'm not.
You did it in pen, huh?
No, I did not.
No, it's pencil.
Oh, cool. Okay. Actually, I should have made anus first, the smaller box, huh? You, my friends, you are butt first organisms.
That's awesome.
It's the first thing that was apparent on any of you when you were like X number of tiny cells somewhere in an amniotic sac. Your anus developed first. The rest of it grew from there. Make of that what you will. Make whatever philosophical assertions about your life and its meaning you will with that. But yeah, your butt first. So, which organisms, so all of them have a mesoderm. Which organisms that all have a mesoderm were head first? Earthworms, snails, and fruit flies. The humans are the only ones on here that are butt first.
So we're special.
Well, don't get ahead of yourself.
No, we're just like
I'm sticking humans over here, but we've still got some other characteristics. So do this in pencil. Of course, I'm doing this on Desiri so I can move stuff around. We know humans are going to be in this, but is that the last characteristic they have?
no.
No, they got a bunch of other characteristics. So we know that they are, head first development. Oh, I put them in the wrong place. Jeez Louise, Moser. Humans. I'm going to stick them there. Okay, so we know that earthworms, snails, and fruit flies are all head first.
Got me off.
Well, we had a split. Somewhere after some common ancestor had a mesoderm, because this is a characteristic that humans and earthworms and snails and fruit flies share, there was a split. And humans have an ancestor that developed anus first. Earthworms, snails, and fruit flies have an ancestor that developed head first. So we have this split in ancestry. The lineage splits. Now let's figure out what other characteristics we've got to work with here. Okay, so I've got these guys, these guys, these guys, and we're getting rid of our starfish. So let's jump down to segmented body. Which organisms have segmented bodies?
Earthworm.
And
Fruit fly.
fruit flies. So we're actually going to do, and I'm going to sort of shrink those for a second. I have a box here. Does everything in there have a segmented body?
Yes.
Check. Snails? Do snails have a segmented body?
Oh.
No.
No.
You're so tired. Me too. I got 4 hours of sleep last night. I was insomniac. Quit whining.
What's insomnia?
Means you can't go to sleep.
I had that last night.
Okay, so which things have a segmented body? So we have earthworms and fruit flies with segmented bodies. What's true of snails? So we've got this and this checked off. Snails, that's chitinous. I'm sorry, calcified shell. Snails have a calcified shell. None of those other things do. So guess what? Snails get a new box.
Happy birthday.
Happy birthday, snails. Calcified shell. We're going to have branches in our cladogram. We're going to have branches. Now, is there anything else that we need to cover for fruit flies? They have a chitinous exoskeleton. So chitin, who here has ever smashed a bug of any sort? Okay. I don't generally smash bugs. Hey, head up, Dante. But if you've ever smashed a big beetle, you know how they kind of crunch? Ew. What you're hearing is the chitinous exoskeleton. So exo means on the outside. They have their skeleton on the outside. You know all that. But the material that's made of is called chitin, and it's softer than bone. It's softer than like a snail shell or a clam shell. It's kind of flexible. It's made of this stuff called chitin. So, of the earthworm and the fruit fly, only one of them has that. I'm going to draw a little box around our fruit fly. Chitinous. I'm going to put X skell. Wow, I can't write that small, can I? All kinds of what? If you say so. Chitinous X skell. Okay, what about our snails? Do we have any more characteristics that we need to add to our snails? No. Now, humans don't have any of those things, but they have one other characteristic. Vertebrae. Okay. How is this going to look as a cladogram?
I have no clue.
Insane.
Not that insane. Not that insane. It's going to have some junctions, yeah. So grab a clean sheet of paper. You can use copier paper right behind Ian. You can use a piece of notebook paper if you want, and we're going to walk through this together. What's our first shared derived characteristic? Cells with flagella. You got them in your body. You've got them in your throat. You've got them in your digestive tract. Cells that have little long tails, whip-like tails that can move stuff. And cells with flagella develops pretty early. And the first species that we find that has them and nothing else is the sponge. Pardon?
This line I just made it so straight.
Awesome.
Crazy, right?
I'm hoping that's not your largest accomplishment for the day.
It is. Right now.
Okay. What's our next shared derived characteristic?
Symmetry.
Symmetry. Any kind of symmetry. We'll take any kind of symmetry you got.
Jellyfish.
Jellyfish have symmetry and cells with flagella. Not a whole lot else. Pardon? Then we develop bilateral symmetry.
Oh, right.
If you're using Doceri, you can just cut and paste the word symmetry. Copy paste. So, bilateral flatworms. Now, this is where we said it gets a little bit more complicated.
We gotta put the thing and we gotta put the fork.
Is there anything here that's got a mesoderm and everything, mesoderm in common and the next step up in common?
Yes.
Yes,
No, we start to split here.
yeah.
This is where we start to split. So once there's the development of a mesoderm, what we see is a branch of this tree goes this way.
What?
And we're going to label this anus first.
This is crazy.
I think this is going to bring something.
I don't like thinking.
Copy, paste. Whoops. Is there a disease what? Okay. Okay, so we have this split in ancestry where we've got, here there's some common ancestor that had a mesoderm and presumably developed head first, but then we have this split where we have organisms that are developing anus first. Do we have anything that is anus first and does not have vertebrae? No. So we can actually finish this line off. Copy, paste, oops. Oh, starfish would have been in there, huh? Yeah. Okay. That's why they included starfish. Just the symmetry thing is kind of irritating. Okay, so once we get to that head first development, we got a split. So we have a branch that goes, this way. See if I can copy that appropriately. Paste, paste. And one branch of this goes segmented body, one goes calcified shell.
Head first.
I probably should have done segmented body on the other side, I'm realizing. Well, just thinking about how mine is laid out, you can do it either way, it doesn't matter. But just in terms of how much room I have, I think that's going to work better for me. Huh?
Yeah, me too.
Okay. So with segmented body, do we have any organisms that have a segmented body but no other characteristics? Earthworms. "27 glorious minutes, my darlings." And we're going to write, I'm just going to write X scale here. Fruit fly, earthworm. So who's got the calcified shell? Snails. Okay. It's not the kind of single straight line that you've had before.
Nope.
But let's talk a little bit about what it shows us. So we're looking at structures. We're looking at structural similarities. We're looking at shared structures between species. Can you put your finger on the last place that flatworms and earthworms had a common ancestor? Try it. Don't yell it out. Don't yell it out. Try it on your cladogram. Point to the common ancestor, the last common ancestor of flatworms and earthworms. I'm going to mark it in purple. It's right there. That would have been the last common ancestor. So flatworms developed this direction. Earthworms evolved a mesoderm. They evolved head first development. They evolved a segmented body. Flatworms got none of that stuff. Where's the last common ancestor of humans and snails? Point to it on your cladogram, and then I'm going to color it in. Last common ancestor of humans and snails is right there. Somewhere after that ancestor, our family trees diverged. We're part of the branch that does butt first. Woohoo. Snails still develop head first. I know, I just like saying butt first. I find it entertaining. Whatever, I'm 12. But those open circles, those junctions, are where we're seeing a common ancestor, and then the lineage splits. And I should probably make that clearer with fruit flies. Oops. We want to make sure that we can You can see that this is a common ancestor. You know, is there another line that develops off that way? Sure. There are multiple lineages of insects. We have wingless insects and winged insects and primitive, I mean, we got all kinds, you know. But this is where we see those common ancestors. Okay. This one was harder. I didn't realize how challenging this one was. What you're going to do now, I have 3 things for you. 3 things. Ooh. One is sort of a web quest. So, have you ever sat around and wondered what a dinosaur would taste like?
No.
Really?
Probably chicken.
I am going to, yeah, probably chicken. Why?
Just because.
Because
Because
birds,
dinosaurs.
because birds are dinosaurs. So, the first thing I have for you is an opportunity to delight your family and friends and possibly earn a little bit of extra credit.
Oh, I guess
Oh, my land.
Oh, my Lanta. You have this handout from the University of California, Berkeley's Evolutionary Biology Department.
Are they gonna send me dinosaur meat?
No, but they have the cladogram for dinosaurs and birds and how they're related. And on the back, they have a diagrammed turkey skeleton, which you can compare to a dinosaur skeleton. They also have directions on how to get a museum-quality skeleton out of your Thanksgiving turkey. So when everybody's done eating all the meat off the turkey, you take that sucker and you pop it in a giant pot of water and you simmer it until you have a nice rich turkey broth. That's what we do anyway. Then you take those bones out, and they've got directions for cleaning those bones to within an inch of their lives so that you get a very nice, complete skeleton, which you could then wire together and put in your living room as a conversation piece when people come over to visit you and they say, "What is that?" And you say, "It's a dinosaur we ate for Thanksgiving last year." And then they shake their
Turkeys are
heads.
dinosaurs?
I have what we ate for dinner and I live.
So now, if you are not butchering your own turkey, obviously you're not going to have a complete skeleton because you're not going to get the head and the legs. When you buy them in a package at the store, those parts have been removed. So it's a little less interesting as a skeleton.
I have a turkey.
You have a pet turkey?
Well,
I killed it.
yeah.
Yeah, I mean, usually I kill my own. I didn't get one this year, but...
It's standing up on my liver.
Oh, okay, one you shot?
Yeah.
Turkey season? Good. Good. So this is the first thing. If you complete... Hey, focus, Pinky. If you complete the cleaning of the bones for me, and you take a picture of it, I'll give you a few points extra credit. You do your turkey skeleton preservation. I don't know how many points. I'll figure that out when you get here and how good it is. Okay, I'll figure that out when I see it. If you take a nice picture or a video of you identifying the bones in your turkey, that would be worth something for sure. You could upload it to YouTube. You could stand there with the diagram of the turkey skeleton and identify the bones in the turkey. I think that'd be hilarious. Your grandma would love it. Don't you think? Man, my grandma would just think I was hilarious.
My
She's
grandma would be
dead,
like,
so anyway, those are options for extra credit. Now, the real stuff you got. You have What Does T-Rex Taste Like? A cladogram web quest. It should be on your classroom stream right now. Yeah.
I think it tastes like alligator.
On that web quest, you're going to open every single folder. You're going to read the pages. When you get to the very end and you have constructed a cladogram, you will screenshot that, and that is what you will turn in. That's easy enough.
Yeah.
When you get back on Tuesday, here's what's going to happen. We're going to do some end-of-course exam questions involving structural cladograms. And we will work on those. We'll talk a little bit more about them. And then Wednesday, of course, we'll go to the museum. We'll look at homologous structures on dinosaurs, and then we'll come back. If you've got paperwork for me for museum or pepperoni roll, please give it to me now.